Thank you everyone for joining us this evening for our latest Tales in Tech and Engineering Insights webinar. My name is Rhiannon and I work in the engineering team at Burnshear, focusing on JavaScript development. And today I'm joined by Jan Trey, who is a developer advocate at Lamigo and independent consultant helping companies around the world adopt serverless. If you do have any questions throughout the talk, please do use the Q&A function at the bottom of the screen. We'll be able to get to them at the end. We are actually recording this talk and you'll be able to find it alongside all of our previous webinars on our Burnshear YouTube channel or LinkedIn. So please do give that a follow. So I'll hand over to you now, Leanne. Thank you so much for joining us.
Cheers, thank you. Let me just quickly share my screen. All right. Okay, so yeah, first of all, I guess thank you everyone for joining us on this talk on the why serverless is a superpower for front-end developers. And I guess personally for me, I started working with serverless technologies a couple of years ago when I was working for a social network startup called Yabble, where we were building like a mix of Instagram, Twitter, and Facebook. At the time, we had this lady called Emily. She was our biggest users, and the whole platform had about 1 million users, and she had about 60,000 followers at the time. And many of these, I guess, influencers on our platforms, they like to do campaigns on our platform where Emily would say, hey guys, vote on this post, and I'm going to announce a lucky winner for this beautiful designer handbag at 10 o'clock tonight. So as you can imagine, throughout the day, there's very little traffic coming to the system, but at exactly 10 o'clock, everybody came in to check whether or not they won Emily's designer handbag. So these kind of systems, this kind of traffic pattern, it makes it quite difficult for engineers like myself who mainly look after the backend side of things and the infrastructure to sort of provision our system so that we can handle these kind of spikes on our system so that users still get a good experience. But also at the time when I inherited the system at Yabble, there was other interesting challenges as well. For example, to deploy an update to our backend infrastructure, it takes 30 minutes of downtime. The whole app has to go down and the whole thing has to come back up. And also more importantly, features work was taking forever. It was taking months to develop a new feature. And one of my favorite speakers in the sort of speaker circuit, Dan North, once said that the lead time to someone saying thank you is the only reputational metric that matters to us as engineers. And it's a message that has really stuck with me ever since. So over the course of the next, I would say 6 months, so me and a very small team of engineers, we fixed most of the scalability and performance issues with the monolithic system that we inherited. And every time we worked on a new feature or had to touch on an existing feature, we made a decision on whether or not to re-architect it with serverless components. So over the course of 6 months, we moved everything over to serverless, but also worked on a lot of new features as part of that as well. So it may look more complex on the right, but remember that all those relationships and dependencies already existed in the monolith. You just don't see them until you dig deep into the code. And the motivation for doing all of that work and new architecture was never about cost. The motivation for that move to serverless was to improve user experience by building systems that are more scalable and resilient, but also we want to improve how fast we're able to deliver features as well. But still saying that, we still found some really nice cost savings compared to what we were paying for on EC2 because we had to pay for a lot of redundant CPU cycles that we're not using because of all the spikes in traffic that we saw. The big beam for us though, however, was how much faster we were able to do. We went from taking months to develop a new feature to sometimes taking a couple of hours, but most likely a couple of days. There was one instance where we wanted to improve the search results so that we surface popular users and influencers further up the results. We decided to use the serverless to do that. Designed the system, we implemented that, we tested that, and we deployed that to production all within the same day. And that was 2016. And earlier this year, I've been working with another client of mine to build a new social network, this time completely from scratch. And I built the whole backend for the first version of this social network in just a couple of weeks, whilst I was working on my own and on a part-time basis because I'm working with other clients at the same time as well. I think the great thing is that in 2020, the technologies around serverless are much more mature and easier to use. And using technologies like GraphQL and AppSync, I can get things done even faster than I was able to do before. which was already pretty fast compared to by most standards. So a few words about myself. I've been using AWS for a very long time now. Since 2018, I've been one of the AWS serverless heroes. And since 2016, I've been mostly working with serverless technologies, including working on that migration for that social network. And these days, I spend half my time working with Lumigo as a developer advocate. And Lumigo is a troubleshooting platform for serverless applications, where you can see everything for your event-driven architecture with Lambda functions and other things in one place. The other half of my time, I spend working as an independent consultant, where I work with other companies to help them adopt serverless technology so that they can go faster. In my spare time, I've written a couple of books with Manning, and I've published some video courses. And I've also been running a podcast every week on the real world use cases for serverless technologies as well. But my journey with, I guess, the cloud and AWS started at the start of 2010. I was making Facebook games at the time at a company called Gamesys. At the time, Facebook games was all the rage, and games like Farmville had something like 250 million daily active users. I was working on games that had maybe about 1 million daily active users, which is pretty small scale compared to some of the top Facebook games at the time, but still fairly significant by many standards, certainly by the standards of what I was working on before. And shortly after that, everyone moved to mobile. And so all the players left Facebook and to jump onto mobile games. And so we moved on to building mobile games as well. And I think that's really changed for me going into, I guess, the cloud and AWS compared to what I was working on before I was working for banks before. Is that now we are building systems that are on 24/7 and used by users that are all around the world. So our systems also have to stay up 24/7, 365 days a year. And also are now building systems that are used by millions of daily active users compared to what I was doing before, where I was building applications that are only used by 20 users within a bank. And this is why I think the cloud is so appealing, because you get all these things around the scalability, around the building things that are resilient to failures and also secure as well. And not to mention the fact that developing with AWS and the clouds is much faster. You can take an idea into the market so that you can start testing the idea against the market very, very quickly. But at the end of the day, AWS and other cloud providers just give you building blocks for what you need to build. To actually build your masterpiece, you still have to assemble all the pieces together yourself, one way or another. So before sort of serverless, to build an app on the AWS, you have to learn a lot about AWS networking in terms of how to set up a virtual private cloud, subnets, net gateways, and all of that to make sure that your AWS networking is done securely and correctly as well. And then you have to think about all the virtual machines to patch the operating system, installing dependencies, creating machine images, and setting out load balancers and all of that stuff. And not to forget that you need to set up logging so that you have got log collection in place. And then you start working on the web server for your application. And after all of this, then you start writing that one line of business logic, which is probably the only thing that your customer actually want from you. They don't care about your networking in the cloud. They don't care about how you set up your load balancers. All they want is, can I log into your application? Can I do something in your app? And I think as Carl Sagan says really well, that if you wish to make an apple pie from scratch, you must first reinvent the universe. And to write one line of business logic in the AWS, I have to set up a lot of things before I can even get there. The worst thing is that all of these things that you have to do are just what you like to call a yuck shaving, which are things that you have to do just to get to doing the things that you need to do. And it's terribly, terribly distracting. And I've always wondered that why can't I just write the business logic and have somebody else deal with all of that non-differentiating heavy lifting? That's it. I mean, even though I don't want to do them myself, but they are still very important and absolutely essential if I want to be set up, if I want to set myself up for success. And just because I can write a very simple, say, Express app, I can put it onto a server, it doesn't mean that I've got a production-ready environment. And for anyone who says, well, it doesn't matter, we ain't gonna need it, all we're gonna need is this one server running our app. Well, you gotta have more faith in yourself than that, because you're gonna work really hard. You and your team's gonna put in a lot of hours trying to build a product. And at the moment you're gonna get some traction, instead of celebrating and getting ready to buy your new Tesla, if your servers can't hold the traffic, then guess what? Everything's just gonna crash and burn along with your reputation. So the hard lesson I've learned over the years is that you always want to prepare yourself for success, regardless. And then along came Docker, and it's supposed to be the sort of savior for us all. And I think the biggest, the greatest trick that the devil pulled is convincing you that once you've got something running locally on Docker, it's production ready, which is far from the case. And to actually do it well, I mean, to begin with, you have no monitoring, you have no logging, you have no scaling. If Docker image dies, that's it, and your app is down. So to actually do it well, you need other tools to help you as well. Things like Kubernetes, things like ECS and Mesos and so on. And then you need other tools for infrastructure as code. So you got Terraform, you got tools for managing credentials and encryption and so on. You got Vault, and then you've got other things that you want to help you do things around your application, like a circuit breaking, like a service discovery, just so that you can route requests to a load balancer, to a container. So you need things like Linkerd, you need things like Istio. So in reality, to get all of that stuff set up and to be actually production ready, it can take a long time. Many companies I know spend months, maybe even years, trying to productionize their Kubernetes and Docker environment. So the reality is very different from the story that many people like to sell you in terms of, oh, with Docker and whatever, when it runs on your laptop, it's going to be ready for production. It's far from the case. And again, I find all of these different tools are great. They're really powerful. They're very interesting, and I love spending time learning them. But then again, they're still just yak shaving. They are just the things I gotta do just so that I can get to doing the things that I actually need to do, which is maybe just writing 2 lines of JavaScript code to implement a feature that my customer wants. It's crazy how much complexity goes into just being able to do something like that. And it's so distractive, and it's actually what I end up spending most of my career, I guess, doing. But I've always hoped for a better way. And increasingly, we're also building systems that have to deal with a large number of users. Users, again, that are global. So our systems have to be up 24/7. And to tackle those complexities, we do need to have a more capable systems, and we do end up building more complex systems. But our brains haven't got any bigger. Unfortunately, biology just doesn't evolve at the same speed as technology. So how do we cope with increasing amount of complexity that we have to deal with in our application with the same amount of cognitive capabilities that we have always had? Well, we can do that by building leverages that allows us to do more with less. And when we move applications from, say, on-premises servers to the cloud, if we're still running virtual machines or running containers, we're still managing infrastructure. And sure, we've got better tools for managing them nowadays with the likes of Docker, with the likes of Kubernetes, but the infrastructure itself is still our responsibility, even if they're far more capable than what we could do before. And I think I love this quote from Matt Klein, who's an engineer at Lyft, and he's also the creator of the Envoy proxy as well. And I think he really captured the essence of the problem here, that unless you are an infrastructure company, the infrastructure is basically overhead. And all the time and energy that you spend on dealing with infrastructure is time and energy that you could have spent on differentiating your product as well. So really, you should be leveraging your cloud provider as much as you can to get them to manage as much infrastructure for you as possible, so that you can focus on the things that are actually important to your business and things that only you can do for your customers. And personally, for me, serverless means technologies whereby I don't pay for them when no one's using them, and I don't have to worry about scaling or provisioning and managing the server themselves. And the funny thing is, since the terms of serverless came around with the launch of Lambda in 2014, I've been able to play this game where every time I say the word serverless, someone reminds me that, but there's still server somewhere, which is true, but it's also completely beside the point. And I think Goiko says it best, that serverless is serverless in the same way that Wi-Fi is wireless, With Wi-Fi, there's still going to be cables. It's just that when you connect to a Wi-Fi connection, you don't have to worry about those cables anymore. They're no longer your problem. And serverless is the same way. So you probably also heard about this other related term called the function as a service, where you will find, I guess, the poster boy for serverless here, AWS Lambda, where essentially what I'm doing is writing a very simple piece of a handler function that accepts some invocation event and some context. And then upload that to the cloud, and then let my cloud provider, AWS in this case, to call my function when something happens. For example, when a customer hits a HTTP endpoint I've set up, or maybe when an IoT device has published a message to IoT core, and I want to run some logic over that event that they have published. And the reason why I think serverless is so exciting, so important for us going forward, is that for starters, you get a lot more scalability out of the box. We don't have to wait for virtual machines to spend 5 minutes to spin up before I can handle my code. The system will handle and auto scale on its own based on the amount of traffic that's coming in. I mean, if you look at the companies like iRobot, who's been 100% serverless in production for many years now, they love the fact that they can sell millions of robots every year, and then everyone's going to open their Christmas gift around like a 4-hour window. And for them, that's no problem. It's just business as usual, even though they experience 100 times the spikes in traffic. Operational wise, it's just nothing different for them. To be able to do that, I think it's just really, really powerful. It really showcases the power that serverless give you in terms of scalability. And you also have other companies like Basel, who are serving 80 million monthly users, again, fully serverless. And Lego has now gone on serverless as well for the e-commerce side of things. And many other companies who are already using serverless technologies. And you also, chances are, unless you're dealing with a system with a consistently high throughput, you may also find your system to be a lot cheaper. In fact, iRobot use serverless as a big competitive advantage, because for them, they sell robots, but they don't charge you for the services they provide afterwards. So it's in their best interest to minimize the cost for managing and running the services as much as possible, and serverless allows them to do that. Also, with Lambda, when you deploy a function, it's deployed to 3 availability zones out of the box. So you get high availability just out of the box without having to worry about that yourself. And since AWS is taking care of the security of the operating system, the networking and so on, and honestly, they can do a much better job than you and me. So it also means that your application itself in turn becomes more secure when you're running on serverless technologies. But for me, the big reason why I'm so excited about serverless and have been using it so extensively the last couple of years is because I can get a lot of velocity between having an idea to having something actually running in production is so much quicker. When you look at what I had to do before in terms of choosing the right language and framework, and then figuring out how to do deployments, CI/CD, configuring load balancers, and all of that capacity planning, most of that becomes either irrelevant or has been at least drastically simplified when it comes to using serverless technologies, which means between having an idea to having something running in production, it's super, super fast. And then a good reason, I think, for foreign developers to really look at the serverless technology seriously is that a lot of people have got a title of full stack developer in their resume, but I think truly full stack developers are really, really hard to find and super expensive as well. Because when you look at the sort of skill sets that's required for front-end and back-end development, what you typically find for full stack developers is either someone who's got a lot of experience working with front-end technologies, CSS, single-page applications, and knows a bit about back-end side of things in terms of setting up infrastructures in AWS, and maybe knowing how to use some of the DevOps tools and understand the scaling applications. Or maybe on the other hand, you find the backend engineers who knows a lot about building infrastructure and backend applications and make them really scale and secure and all of that, but maybe just know enough about front-end technologies to work on a project with other more specialized front-end developers. To find someone who's equally skilled in both is really, really difficult. I know because I've been trying to hire them for many, many years. But when you look at this, I guess the amount of things you have to learn compared to, with running applications on containers or on EC2 compared to running stuff on serverless technologies, the bar is much, much lower. On the one hand, if you want to learn everything you need to be able to build truly production-ready applications in AWS, not just I've got some Express app, I'm going to throw onto one server and hope everything's okay. You have to learn an awful lot about networking, about virtual machines, about security, about distributed systems. All of that is akin to if you want to build a toaster from scratch, you're going to have to work out how to acquire minerals and how to use a furnace and how to melt metal and mold the casing and all of that. Whereas with serverless and Lambda, you have to learn something still. Of course, it's no free lunch, but it's more like how do I use a commercial toaster? Put my bread in the right place, choose the right setting, and press a button, and then just wait for it to be done. The bar is much, much lower. You still have to learn, of course, especially when you're completely new to AWS and cloud, but the amount of what you have to learn is much, much lower. The bar is significantly reduced. In turn, it means that I'm finding a lot of front-end focused teams are able to get what they need to do done without having to require a backend specialist that comes in to help them setting up everything from scratch. Equally, if you're a backend engineer working on some system, you can also get much more done with a lot less effort and stress as well. So as I mentioned, I work on a social network with a client of mine where I build the backend for the social network in just a few weeks using serverless technologies and GraphQL by just using some services from AWS, services like AppSync for manage the GraphQL and then connecting them to DynamoDB or to Lambda or to Elasticsearch to implement different features. And I can get so much done on my own in just a few weeks working part-time, which is something that I would never be able to do before if I have to configure all of the networking, all of the virtual machines, patching them and setting up load balancers and all of that stuff. Which means as a front-end focused team, you can really focus more of your time and energy on improving the user experience and improving the UI, which as far as users are concerned, is the system. And many of the users don't even realize there's a backend out there. In fact, me and my friends who's been working in this sort of AWS and cloud for a long time, we have this joke that you only talk about backend when it's not working. And backend systems should just work. And it shouldn't really be that hard. And I think with serverless technologies, they don't have to. And one thing I also want to touch on as well is I'm finding many of these teams, front-end focused teams, are now making the jump to start using serverless technologies. And they're making some quite common mistakes, especially around the use of async and await in the Node.js code. For example, with Lambda, you can write your Lambda functions using async and await, and you can still optionally take in a callback. And I still see people use both async and await and callback, which is just is really clumsy and it just makes the things a lot more confusing. So just use plain async await and also try to avoid mixing callbacks with promises, which also just makes things so confusing. In fact, I was helping someone the other day who was finding that the function just finishes before it does what it's supposed to do. And it was also, when you looked in the code, it's all because there's callback and then there's promises and there's some promises weren't being awaited. So the code just finishes before the actual promise is actually completed. And also I find I guess on the flip side, async await allows you to make asynchronous calls and wait for them, make them more sequential without having to use callbacks. But at the same time, sometimes you just want to do things in parallel or concurrently as much as you can. So you can also take advantage of the fact that you can kick off multiple promises and then await them later. So in this case, the example on the left does the first thing, then the second thing, whereas the code on the right here will kick off both, and then after they started, then wait for them to both finish before returning, which allows you to execute more things in parallel and improve the performance of your code. And then a big one that stung me a few times, as well as my client, is that again, with promises, when you've got an array of promises, so the code on the left doesn't work the way you expect them to. Instead, the way you need to do is you need to capture the array of promises that's been returned, and then use a promise to wait for all of them to finish. Again, there's so many things like this around the promises, which has got people quite a few times. And this one has got me personally, has been a gotcha for me a few times as well, that where you've got an array of for each in the Node.js, and you're passing in an async function in there. This doesn't work. You have there's a specific reason why it doesn't work the way you expect them to. If you run this code, it's going to print the all done straight away. So the way to do this really is to use a normal boring for loop instead. And when you're using Lambda, you're probably going to be using the AWS to talk to other AWS services a lot. And that's another mistake I've seen people make, is whereby when they're using the AWS when they make a request, they're not using the .promise option to then get a promise back from the request, so they can await that rather than have to use the callbacks. And once you start working with Lambda, you probably very quickly hear about this thing called cold starts, which is like I guess like the boogeyman when it comes to server applications, whereby it's probably been made a much bigger deal than it actually should be. Basically, what happens is that when your system have no request, Lambda would scale down to 0 containers, so that nothing is running, so you don't pay for anything, which is great. But when there's a request comes in, it starts to auto scale based on how many requests coming in and whether or not there's a container that's already been created to handle requests. And when it needs to create new containers to handle your code, to handle the requests that's coming in, it's going to have to initialize the container, initialize the runtime for Node or for Python or for Java or whatever language you want to use. And then you have to initialize your module as well. So if you got the dependencies in the globals, then this is where the initialization happens before it then executes your code. So these 3 steps together is what we call a cold start, and this happens on the first request. A container has a handle. So one common misconception I've heard about these cold starts is that, well, you only experience cold starts every time you deploy a new version of your function, which is not the case. Is the first request to a new container that's being initialized. And I think the reason why this misconception exists is because we don't have a good vocabulary that separates different, I guess, concepts here, where we got a Lambda function, which is the code, the permissions, the configuration. We got a concurrent execution, basically a container that's running your instance of your function. Even though under the hood, they don't actually use containers, Lambda doesn't run on Docker. It runs on proprietary technology based on AMIs, and which allows the AWS Lambda team to optimize the performance of that cold start, and which is why they have a better cold start compared to the other cloud providers. And then there's an invocation of your function, which is going to be a request that's been coming from a user or from some other parts of the system. So if you think of them in terms of the terminologies from OO, a function is basically a class. A concurrent execution is an instance of that class, and an invocation is a method call against an instance of your class or an object. And the great thing about Lambda is that it auto scales the number of concurrent executions based on your traffic. If there's more traffic coming in and you have no spare containers to handle new requests, then Lambda is going to bring up new containers automatically to meet your request. But when the request goes away, then the containers become idle for a certain amount of time. They're also garbage collected and scaled down to 0 as well. And whilst they're running, you only pay for requests that are actually happening against your function. You don't pay for when they're sitting idle. And as much as possible, those existing containers will be reused to handle new requests, so to minimize the amount of cold starts that you actually have to see. So let's walk through a very simple scenario whereby I've got a function and a request comes in. So Lambda sees that it has no containers, so it creates a new one to handle this request. So this is going to be a cold start. So whilst my function is handling this request, another request comes in. So this time, Lambda says, okay, I don't have a spare container. So what I'm going to do is I'm going to create another container to handle this second request. So you get another cold start to get another container to handle request. Nothing happens for a while, and then two requests comes in at the same time. In this case, well, we got two containers already. Great, we're going to reuse those, so there's no need to bring new containers up. So no cold starts here. But whilst we're doing that, if another two requests comes in at the same time, then again, Lambda have to bring up two more containers, initialize them, and therefore you see two more cold starts. Some time passes, nothing's happened, a new request comes in, it gets routed to one of the existing containers, and then again, another request comes in afterwards. And after some time, those other containers that's been idle for a while, they get garbage collected. So the resources that's been used up by them are freed up to be used by other users or other functions that you're running in your account. Until eventually that last container you've got is also been idle for a while, so it gets garbage collected as well. So Lambda scales whole system down to 0. And it's because of this behavior that's based on traffic, we can see that if I replay a HTTP request 100 times at the concurrency of 1, then you see that only the first request was significantly slower than the rest. And this tells me that this was a cold start. So 1 out of 100 requests being a cold start, which is not bad. But what happens if we change 100 requests so that they are fired at a concurrency of 10? Then all of a sudden it paints a very different picture. So now the first 10 requests are all going to be cold starts, and they're all going to be slow as well. And the point here really is that the frequency of cold starts is determined by your traffic pattern, which is, if you're building APIs, then it's not something that you can really control. But when you think about cold starts, you need to think about it in terms of both frequency as well as duration. And since the frequency of your cold starts is a function of your traffic pattern, something that you can't control, generally speaking, unless you're talking about traffic that's coming from system events like cron jobs and things like that. What you could do but you can control, you have some control over the duration of your cold starts. So if you're thinking about dealing with the problem of cold starts, then I would say start by focusing on reducing the duration so that even when they do happen, they still fall within your acceptable latency range. And also, I guess one thing that I see a lot of people do when they first move into serverless, coming from the sort of Node.js or JavaScript world, is they find tools that allows them to run an Express app inside a Lambda function. So I think that is a great option for you to lift and shift your way into serverless and get some of the sort of automation you get with Lambda, some of the better scalability and all of that. But if you want a good performance and you want to reduce cold start performance, cold start duration, then you don't want to be running Express app inside a Lambda function. And I will talk more about that, why that is the case in a minute. And before you say, well, cold starts are terrible and Lambda is not a suitable solution for me because of cold starts. And I do hear this argument quite a lot. But first thing I think you should do is be honest and say and write down what is your actual latency requirement here. For most web applications, I guess a common latency requirement I hear is, well, at the 99th percentile, we need to have a response time or latency that's less than, say, 1 second or maybe up to 3 seconds. And if you've got the application that you're running and the latency is not user facing as well, then you also probably don't have to worry too much about the cold starts because these are background jobs that's happening. So in the iRobot example, for example, they run a lot of events processing based on the events those robots are sending up to the AWS cloud via IoT core. So they have cold starts all the time, but it doesn't matter because those latency doesn't affect user experience. It's just a robot that's listening, maybe waiting for a bunch of milliseconds, a bit longer for response from the cloud. And also, don't forget that what we're talking about here ultimately is sporadic spikes in latency, and they have existed long before Lambda, or for very different reasons. For example, I've seen them in terms of garbage collection pauses, which is quite commonplace, especially in the managed languages, including Node.js as well. Or maybe we've seen it when our server has been overloaded. Once our server hits more than, say, 75% or maybe 80% CPU, latency is going to really spike up. And when that happens, it's not just 1 or 2 requests, but it's more like every single request just feels really, really slow. You don't get this kind of overloaded server scenarios with Lambda because every single request from the HTTP from API is going to be handled by a different instance of your function. So literally, you cannot overload the server in this particular case. And also, or you can find your application becoming slow and sluggish because some downstream systems you're talking to, it could be databases or it could be other third-party services are being slow. And of course, these are still going to impact us when it comes to Lambda as well. And of course, there are also going to be occasionally latency spikes because of underlying networking issue happening in AWS. And ultimately, now I want to stress again that cold starts is also, generally speaking, not a problem if you've got a steady traffic pattern, because the traffic itself keeps the existing containers warm, so you don't need to see new containers and therefore no cold starts. So iRobot, for example, their system receives events and pings from the robots, and the sort of traffic pattern is very predictable based on the size of the number of robots they have out in the wild, which grows steadily over time, but it's predictable nonetheless. But on the other hand, if you say you're at the Zone, which is a big sports streaming platform I used to work at, where we had the spikes of like 1.2 million concurrent users. So we see massive spikes just before a football match starts. So these kind of systems are not great when it comes to dealing with cold starts, because when the users when the spikes come, every single request is going to be a cold start. Equally, if you say you just eat, where also used to work, we saw spikes at around lunch and dinner time. Again, that means when these spikes happen, probably every single request is going to be a cold start. So these scenarios are not great when it comes to cold starts. And so we talked about you want to minimize the cold start duration so that they fall within your acceptable latency range. If you can do that, then great. And there's a couple, and especially for Node.js applications, there's a few things you could do to really help you reduce the cold start duration, so that hopefully you can bring them down under your SLA for latency, so that even when cold starts happen, they're not a problem for you, because your target is have say 99% of requests be completed within 1 second. One thing you could do is when you're using the AWS DK, don't require the full AWS DK, but require just a specific client. And then you can use things like webpack to bundle your function during deployment as well, which really, really helps when it comes to reducing the cold start duration, because much of the time that it takes to initialize your module is to do with the file system calls when you say require something, because those have to check the file system, have to load files and so on. So something like webpack or any other bundler for that matter, what you can do is that you take all of that and turn it into one big file. So at runtime, there's no file system calls to load additional files. So I did some experiments to collect data about how much of difference it makes if you just make these two very simple changes. And you can, just by making these two simple changes, you can save yourself on average about 250 milliseconds of your cold start time. So for most of my applications, this is all I have to do to bring my cold start latency down to an acceptable range for my application. And for Node.js applications, you can probably get cold starts around the 300 to 500 milliseconds with just these two simple changes. And if you say, okay, we've done our level best, we've optimized our code as much as we can, but our code start is still not good enough. Maybe you're running on, Java, or you got some really heavy dependencies. You're doing some, server-side rendering with React, perhaps. So the dependencies are so heavy and so big, and then doesn't matter what you do, you still seem pretty heavy cold start. Then what you can do is you can use this feature called the provision concurrency, which basically allows you to pay for a certain number of containers to keep them warm all the time. And in this case, you can also programmatically increase them as well, so that if you say just eat again, so the spike is going to come around lunch and around dinner. So before they come, you change your provision concurrency to bring them up to the level that you think you're going to need to handle the requests. And then when a spike finishes, you can bring them back down again, so you don't pay for extra hours for those provision concurrency. And the great thing about provision concurrency is that it works in tandem with the normal on-demand behavior, whereby if the spike is bigger than you imagined, you haven't provisioned enough containers, then it doesn't matter. The actual request would just be handled by the normal auto-scaling behavior that Lambda gives you, So you're not gonna sort of miss any requests or give return 503 for your users. That said, provision concurrency is not a silver bullet by any stretch of imagination, and in fact, it is a powerful tool, but it has got other, I guess, baggages that comes with it, other additional complexities. So you should only use it if you've got a problem with CodeStar that you can't just optimize your code and be done with that. And then great, use provision concurrency, but otherwise you shouldn't be using it by default. And that's kind of everything I wanted to cover in this talk. And I want to give you guys plenty of time to ask your questions as well. I think we've got a couple just been submitted to the Q&A widget and in the chat as well. Before we go, I just want to mention again that I'm an independent consultant. I work with lots of different clients on their projects. So go to theburningman.com to check out the services that I offer. And I'm also running an online workshop in September where it's going to be a 4-week self-paced workshop where you're going to build something from scratch, and you're going to get plenty of hands-on exercise on how to do testing, CI/CD, and how to build APIs and data processing pipelines with Lambda. And you can get a 15% off with the code YENPRS15 as well. So with that's everything I wanted to cover for today in the main session. So Rhiannon, I guess we can have a look at the chat and see what questions we have. So we've got a couple questions in the chat here. One question is, are you excited about any upcoming features or tools in the serverless world? So there's a couple of things that are in the pipeline that I can't really talk about under strict NDA here. But certainly, I think in terms of tooling-wise, there's a lot of new tools now that's been available over the last couple of years that wasn't around when I first started. Tools like Stackery, I think, really makes it a lot easier for, at least for people that are sort of new to AWS, to start building applications and then provisioning resources and really sort of visualize the resource graph, like, oh, here's an S3 bucket that's connecting to a Lambda function that gets triggered when someone push an object into S3, or here's an API gateway, here's a URL, and here's the Lambda function behind it. So Stackery makes it really make it a lot easier for you to sort of deal with that complexity without having to sort of dive into YAML. At the same time, I also, but personally, I still use the Server framework an awful lot as well. That's my sort of my default. Okay, that's actually got a question here about the Server framework. So someone asked, why use the backend deployment framework like Serverless versus Amplify? Please talk about trade-offs of each. So I guess why use the server deployment framework to begin with? Well, if you don't use it, then you're probably going to end up using something like CloudFormation, which is still quite verbose. You end up writing a lot of code to describe the resources that you want. And also, it doesn't offer you any opinions on what are the sensible defaults. So frameworks like Serverless, frameworks like SAM, they provide the more opinionated defaults for these configurations, but also makes it a lot easier for you to configure your resources. So I can just say, okay, for an API, I just want to say what's the URL, the Lambda function behind it, and whether it's the HTTP method and like that, without having to write, I don't know, 20 lines of CloudFormation code to describe the same resource. At the same time, with Amplify, I find is great when you sort of really want to quickly bootstrap a project, but you end up just running a few Amplify CLI commands, and rather than having a proper infrastructure as code, you end up just you have your bash script or sort of kind of you end up doing. And Amplify CLI is great for just putting something up really quickly and then to build a proof of concept. But to have a proper infrastructure code, I still prefer to use one of the other frameworks out there. But Amplify is also more than just a CLI. There's the client-side library, which I've been using for my projects. And it really makes it easy for you to do a lot of the authentication, especially with Cognito. And then there's also the Amplify service itself, which lets you basically say, point it at a repo, at a branch, and then you can do a lot of the sort of CI/CD and deployment for you for your single page application, which is pretty great. I guess a very close thing to Amplify would be Netlify, which is also an amazing product as well. Server framework itself also, compared to the other frameworks like SAM, is on a similar framework like serverless framework. SAM, I guess is the main one. There's also Chalice, Cloudia, and things like that. I guess the big two in that particular space is serverless framework and the SAM. The reason why I prefer the server framework is that it's got a really rich ecosystem of plugins that make it really easy for you to do things and disagree with the framework. Whereas with SAM, you kind of stuck with what SAM decides. There's no escape patch, at least not easily. So there's one time I had to do something that goes against the default that SAM has, and I had to write a CloudFormation macro just to change like one line of configuration in the CloudFormation template. With a server framework, that can be really done easily with the plugin. And then the capabilities that's not built into SAM, sort of server framework, you find plugins for pretty much everything. And then there's also the new breed of tools like CDK and Pulumi, whereby you can provision your resources using general purpose languages like TypeScript or Node.js or C#. Personally, I really like the fact that you get some IntelliSense support with CDK, and well, you get better IntelliSense of support. The problem I find with those tools, CDK and Pulumi, is that you open a possibility for arbitrary complexity in your infrastructure graph, whereby two different people can write different code that arrives at the same resource being provisioned. And also, especially in a large company, this can be problematic, whereby different teams just decide to use different language. So that as the sort of in terms of centralized governance, or having an ops team that can help other teams to do the right thing and provision the right resources and follow organizational best practices, it also becomes difficult for them to then have to be able to work with different languages. Or also, when people move from one team to another, potentially that creates another point of friction. But that said, CDK has got some really amazing constructs that you can use out of the box, so that you can, rather than provision individual resources yourself, think of it as a high-level construct whereby I want to have something that's got an S3 bucket and that triggers a Lambda function, and I just want to write some part of that and just bring that as a pattern into my application. So CDK provides a lot of that constructs for you. And the question, okay. Areas of development and product experience you feel serverless is better versus typical microservices. First, I would say when I'm building serverless applications, I'm still building microservices. I'm still using the same, I guess, principles around the bounded context, around the separation of responsibilities, and the building systems through events and decoupling them. So microservices doesn't mean it's containers, doesn't mean that it's EC2. It's about the bounded context, about allowing to scale your team, so that not everyone has to work on exactly the same code base and step on each other's toes all the time. And when I'm building serverless applications, I'm still following the same principles. Question, is there any serverless framework plugins to get rid of cold starts? They don't get rid of cold starts. There's this thing called the Lambda warmer, which essentially is a cron job that paints your function, but it's only effective when you've got, say, 1 or 2 concurrent executions. Because when you fire a request, you can't say which container is going to hit. And so I find it useful only in the case whereby I've got endpoints that are literally never used. So every time it's used, it's a cold start, so which is going to be really annoying. So things like, I actually had an endpoint that returns the legal document for the app, which means no one reads that. Every time someone uses it, it's a cold start. So that's the only use case I find with Lambda warmers. Other than that, if you want to get rid of a cold starts, then use provision concurrency. All right, got some questions in the Q&A widget as well. Got a question for here. Based on your experience, what other constraints are specific of services running on AWS Lambda other than the cold starts? Thank you, fantastic talk, by the way. Thank you. So constraints, so there are constraints around the execution time. So you can only run your function for up to 15 minutes. You can work around it using clever things like writing your function as a recursive function. So if you can't finish the job, just recurse. And that kind of works, but it requires you to be quite careful in terms of checking termination conditions and things like that, so that you don't end up with infinite loop. So if you've got something that's long running, like a big ETL job that have to run for a couple of hours, then probably better to run it inside a Fargate task instead. Fargate being, I guess, almost like a serverless container where it takes care of a lot of the sort of infrastructure. So you don't have to provision, you don't have to provide your own EC2 cluster. You just say, I want to run this container as a task and just run it until it's done. So for long running tasks like that, I would say use the Fargate. Other constraints around there's the memory size, there's a storage space, which are gradually being locked down, removed as constraints. For example, before you're limited to 512 megabytes of disk space. So if you want to do machine learning and some of the machine learning training, things like that with TensorFlow, for example, you're going to be out of luck because TensorFlow models are pretty big, and plus the execution time is also runtime is also pretty big as well. So recently, Lambda introduced EFS integration. So essentially, what you can do now is put those big artifacts into EFS or Elastic File System, so that your function can load from the EFS rather than have to be bundled into your artifact, and then you run into the 512 meg limit, even though you got more memory than that. So those are some of the limits that you got to think about. But other than that, more and more you finding those constraints are being sort of lifted by new platform features. Got a question here. What are your opinions of services like Vercel, formerly Zeit? I think it's great, especially for the teams that are focused on the front end and just, I don't need to sort of tinker with all this backend infrastructure. Just give me something, give me like a database you can put stuff into, or I want to just run as much of it for me as possible, and give me a more sort of productive abstraction. So things like I think Vercel is really great for that. There's also other ones as well. I think there's one called the Begin, and then there's. But yeah, Begin and Vercel, I think those platforms are really powerful, and I'd love to see them go a lot further. And I think Vercel is doing really well as well in terms of hosting applications for front-end focused teams. Question here from Nima. You said don't use Express if you can. How about Nest.js? They provide a lot of tools that make backend engineers' life easier for bigger projects. I haven't used Nest.js, so I can't really tell you. But ultimately, I would say double check how much. The main thing to look out for is how much they add to your code start time. So the reason I'll say Express is a bad idea is because it's quite a heavy dependency, which means that it's going to add quite a bit to your code start time. But also, when it comes to building APIs, you want to have, as much as possible, individual endpoints be an individual Lambda function, so that you can be really granular in terms of how you provision the permission for those functions, so that you don't have one function that does everything. And so if you got an API that does lots of different things, then that one function can have all the permissions, which means that if it gets compromised, then the attacker can then do a lot more. So when it comes to security, one of the sort of the golden rule is the principle of least privilege. And when it comes to Lambda, you can be very granular in terms of the permission you give to individual functions. But to do that, you also need to have more granular functions as well. So the best practice is usually to have one function per endpoint. Which of course does mean that there's a bit more configuration, a bit more sort of plumbing you got to do. So for bigger projects, I guess I can see that the reason why you want to use something like Express or Nest to make it a bit easier for you to sort of scale those projects. Okay, one more question. Do you feel serverless kind of movement actually started with Google App Engine? Good question. So I think I actually used Google App Engine back in 2010 when I was at the GameSys. Amazing platform. But I also think that they kind of missed a trick there, because it's almost like halfway. So the whole sort of, I guess maybe serverless movement, maybe it didn't start there. Even before that, 2004, if you listen to Simon Wardley, his company at the time, I had probably what became maybe was probably the first function as a service thing, where with Google App Engine, that's what I guess you call platform as a service, whereby you upload your Flask app and then you still have to configure things like number of front-end instances. So you have to configure a lot of information about how many servers I'm running and the size of the servers. But also you have to pay for those servers and pay for uptime, even when there's no requests going to them. So it's a different model, but I would say it's probably like some people say that BDD is the TDD done well. I'll probably say serverless, or the modern interpretation of serverless is what platform as a service should have been. Yeah, that's my thoughts. But I do like Google App Engine. I just wish that they had gone a bit further, which I think are kind of what you see now as a functional service is what Google App Engine could have been. I love the Google App, and I really hope Google have done more with Firebase as well. Again, really amazing platform with lots of potentials, but they kind of just missed a trick there. All right, so I think those are all the questions. Right about time as well.
Perfectly timed. Yeah, no, thank you, Jan, for that talk. And thank you for everyone joining us this evening. Definitely keen to hear any feedback or topics for future webinars, or of course, if you'd like to speak on a topic of your choice. Feel free to get in touch with Jan if anyone has any further questions. He actually has loads of other serverless talks on his website, which you can find at theburningmonk.com. And you can find me on LinkedIn or get in touch at rhiannon@burnshire.co.uk. Thank you again, everyone, for joining, and to Jan for a great talk. And yeah, everyone have a lovely evening.
Cheers. Bye-bye.
Cheers. Bye.